So when looking at this next example, which I'm calling example 1, in this case, we're just going to solve for the horizontal asymptote. And we're going to set this up a little bit different than how it is set up right now. Right now, you notice that we do not have a denominator. And because of that, one of the things that we can do is we can set this up as the limit of x approaching positive infinity for the square root of x squared plus 1 minus x. And we'll set that up as division by 1. So there's not a whole lot that we can do with the denominator. We don't have a variable or a highest power variable with which we could divide the numerator and denominator by. So the other thing that we have in our toolbox is the conjugate. So we can take the conjugate of x squared plus 1 minus x, and the conjugate of that would be plus x. And to make sure that this is still the same value, we must do this for the numerator and denominator. Which gives us, as the limit of x approaching infinity is now going to be, and this is the difference of squares. So we multiply the square root of x squared plus 1 times itself is going to result in x squared plus 1. The difference of squares means that the middle portion of this is going to eliminate itself, and we're just going to have negative x times positive x, which gives us negative x squared. The denominator is a product of 1 times this entire term. So we end up with the square root of x squared plus 1 plus x in the denominator. So at this point, you can see that in the numerator are x squared and negative x squared cancel each other out, leaving us with just 1. So let's rewrite this again. So we now have the limit as x is approaching infinity is going to be 1 over the square root of x squared plus 1 plus x. Now in the last video, I stated that, or referred back to rule number 6, and this will keep coming up. Rule number 6 states that for any value divided by the variable, regardless of the power that it's raised to, is always approaching 0. And I can show you that here, that in this graph, we can see what this function is actually doing. As we are approaching greater and greater values for x, the graph of this function's curve is getting closer and closer to 0. But we can continue on, and I will show you that if we take the lead variable from the denominator that we've created and divide each term in the numerator and denominator by that, I can show you how we're ending up with 0 if we just go a little further. And also, I want to show you how this works with a square root. So we have the square root of a variable, x squared. So let's write that over here. We have square root of x squared. And we should know that we can rewrite that in exponential form. And that would be the power of 2 that it's raised to, divided by the square root is 2. Well, that's equal to just x. 2 divided by 2, that's just 1. So x to the first. So really, writing the square root of x to the second is the same as writing x to the first power. Well, in the denominator, we only have x to the first power for both variables. Both of these are equivalent. They mean the same thing. So let's go ahead and divide the numerator and denominator by that highest power variable of just x to the first. So we're going to multiply the top and the bottom by 1 over x, or 1 divided by x. And we end up with the limit as x approaches infinity is going to be 1 over x divided by the square root of x squared plus 1 plus x, and each of these are going to be divided by x, each term. Now make a little more room here. So at this point, you can see, hopefully you can see that in the numerator, again, by rule number 6, states that 1 over x is going to approach 0. This goes to 0. And immediately, when that goes to 0, it doesn't matter what's in the denominator. And the reason is that anything that is 0 divided by, well, anything, is going to be 0. And again, the graph of this function's curve shows that. But what if we continue on? What more can we do? This would not be necessary, but we can continue on just to show how we can take care of this new problem that will arise in your homework. How do we reduce that? So again, we said that if we have the square root of x squared, its equivalent is x, which means that the reverse is true, that if we have an x, we can raise it to the second power and make it a square root. And now we have a square root over a square root. And what we can do with that, and I'm just going to show you what we're going to do with this. We already know that our limit as x approaches infinity is 0. But I really want to show this. So if we have the square root x squared plus 1 divided by square root of x squared, because we're saying that x is equal to x squared. So what we've done is we've just changed the look. But essentially, we can now say that it is x squared over x squared plus 1 over x squared under that square root. By making this a square root, we have allowed ourselves to split these into separate terms, which allow us to reduce this. This becomes 1. And of course, 1 over x, or 1 over x squared, becomes 0. And we now have a square root of 1 plus 0, which is just simply the square root of 1, or 1. So this expression in the denominator, this expression would actually become 1. That could become 1. But again, we already know that the solution to this limit as x approaches infinity is 0. And the reason for that is that we have 0 divided by anything is still 0. But I hope this is helping, and I will have a few more examples as we approach some more horizontal asymptotes. Thanks for watching.